Hello and welcome back to our channel. And today we are going to look at percentages. In this unit, we will be talking about the advanced application of percentages, profit and loss, discount, and taxes, which includes GST. So let's get started. So in the previous classes, we've learned about the simple applications of percentage. But in this class, in class 8, we will be talking about the advanced application. So let's first jog our memory down to what a percentage is. So, in the formal definition, the word percentage means per hundred or something or a number out of 100. Let's look at it through the lens of an example. So, in this question, student A has got marks of 95 out of 100, and then we need to find out what the percentage is for that. So, in order to find the percentage, we will first need to put the marks divided by the total number of marks, and then we will need to multiply it by 100 to get the out of 100 or per 100 field. So as in this case, it is already out of 100, we get 95%. This adding of sign is necessary as it denotes the percentage weightage. And in simple terms, percentage is the numerator of a fraction with the denominator of 100. So now we will look at a simple case of converting a percentage into a fraction. So in order to convert a percentage into a fraction, we will first replace the percentage sign with a 1 by 100 and reduce the fraction to the simplest form. Let's look at it through an example. Let's say we want to convert 20% into a fraction. So 20% can also be written as 20 over 100. And when we simplify this comes out to be 1 by 5. Similarly, we can also write 75% as 75 by 100. We convert it into the simplest form, and this gives us 3 by 4. Now let's look at how to convert a fraction into a percentage. So in order to convert a fraction into a percentage, we will multiply the fraction by 100 and then put the percentage sign behind it. Let's see this in action. So let's convert 3 by 25 to a percentage. So first we will multiply the 3 by 25 into 100 and then simplify this to get 12, and then we'll add the percentage sign to it. So that becomes 12%. Now let's look at how to convert a percentage into a ratio. So first, if we want to convert the percentage into a ratio, we first need to convert the percentage into a fraction and then convert it into a ratio. So the fraction in the simplest form can be written again as a ratio. So that's how it goes. Now I've created this simple flow chart for you to see how it works. So we have the percentage sign, which first converts to fraction in the simplest form, and then it goes on to become a ratio. Let's look at it. Let's look at it through the lens of an example. So say we have 28% and we want to convert it into a ratio. The first step is to convert it into a fraction. So 28% can be written as 28 by 100, which can be simplified to 7 by 25. And then this is, as 7 by 25 is the simplest form, we can write it as 7 is to 25. Similarly, let's say we have a different kind of a percentage, which is in a mixed fraction form. We'll first convert this into an improper fraction of 200 by 3, and then convert it into a fraction 200 by 3 divided by 100, which gives us 200 by 3 into 100. And this gives us the value of 2 by 3, or the ratio of 2 is to 3. So let's convert a ratio back into a percentage, and we follow the same route in reverse. So we'll first have the ratio, we convert it into fraction in simplest form, and then we convert it into the percentage form by multiplying it by 100. So let's take an example. Say we have 1 is to 4 and we want to convert it into a percentage. So 1 is to 4 can be written as 1 by 4, and when we convert it to a percentage, it becomes 1 by 4 into 100. So it can be written as a percentage. And when we simplify this, we get 25%. Similarly, can be done for say 3 by 8. We convert it into a fraction of the simplest form, that is 3 by 8. In order to convert it into percentage, we multiply this simplest form fraction into 100. And then we simplify this to get 75 by 2. or 37.5%. So now we will look at how to convert a percentage into a decimal. So let me create the flowchart again. So we have a percentage. Convert this percentage into a fraction by multiplying it by 1 by 100. That becomes a fraction. We convert it into simplest form, and then we convert that into a decimal. So let's look at it through a lens of an example. Say we want to convert 36% into a decimal. We can write that as 36 by 100 as we multiply 1 by 100 to it. Then we simplify it to get 0.36. Or we can keep it just like that. We can remove. We don't need to go it into the simplest form. We can just put the decimal if there's 100 below it. Now let's look at how to convert a decimal into back into a percentage. So say we have the decimal. We'll create a flowchart again. Convert it back into a fraction. And then we multiply it by 100 to get our percentage. Let's see this through an example. So let's say we want to convert 0.75 into a percentage. So 0.75, we convert this decimal into a fraction, that is 75 by 100. And then we multiply 75 by 100 into 100. Simplifying it gives us 75%. So let's find the percentage of a given quantity. So we follow this rule of thumb where X percentage of a given quantity can be calculated by putting X by dividing X by 100 and multiplying it by the given quantity. Let's see this through the lens of an example. Say we need to find 75% of 12. What's the value of that? So using this above, we will use 75 by 100 into 12, and that gives us 9%. Sorry, it's just 9. Now it's time for some example problems. We should make the concept of percentage clearer for you. So in this question, we have that it says that 72% of 25 students are good in mathematics, and then we need to find out how many students are not good at mathematics. So let's first find out how many students are good in mathematics. So following this, we have number of students good in math, 72% of 25, and that comes out to be 18. Now we know total number of students is 25. So the number of students which are not good at maths would be total number of students minus the number of students which are good in maths. So the total number is 25 minus 18, which is the number of students which are good in math, and that gives us 7. So our answer is 7. So now we look at how to express one quantity as a percentage of other quantity. And we follow this particular rule of thumb. We have x by y into 100. So we are expressing x in terms or as a percentage of y. Say the x value stays. So the number that needs to be expressed as a percentage, here it's x, it stays in the numerator, and the percentage of which you need to create the percentage stays at the bottom or in the denominator. We'll follow this rule of thumb in the upcoming examples. So if x percentage of a quantity is y, then the total quantity can be expressed as y by x into 100. We'll look at it through the lens of an example, then it will be a lot more clear. So let's express 150 gram as a percentage of 6 kgs. So our required percentage is 150 grams because we need to keep all of this in the same unit. So we have 150 grams upon 6 into 1000 grams. So that converts the grams in the kgs into the grams into 100. And that gives us 50 by 6% or 2.5%. Similarly, we can also do another question where we have 20 paisa as a percentage of 4 rupees. So we know 1 rupee is equal to 100 paisa. So required percentage would be 20 paisa. We'll convert everything into paisa. upon 4 into 100 because every rupee is 100 paise. And then we'll multiply it into 100. And that gives us 5%. Let's move on to some word problems. So this is a very simple question. Let's get started with it. So in a class, we have there are a number of girls and number of boys, and 60% of the total number of students are girls, and that is given to be 18 girls. And now we need to find the total number of students in the class and also the number of boys in the class. So let the total number be x, and then we know 60% of students, that is 60% of x, or 60 by 100 of x, are girls. And then it says that the number of girls in the class are 18. So we can equate these two. So 6 by 10 x is equal to, I've just removed the zeros. So 6 by 10 x is equal to 18. We'll simplify this to get the value of x as 18 into 10 by 6. And x comes out to be 30. So that is the total number of students. So because the class only consists of boys and girls, so the number of boys would be the total number of students minus the number of girls, and we know the value of both. So number of boys can be written as total minus girls, which comes out to be 30 minus 18, and that is 12. So basically the percentage increase in value can be found out by dividing the difference of the original value with the new value, and that is the increase in value, divided by the original value, and then multiplying the whole thing by 100, and that will give us the first increase percentage. And similarly for the decrease in value percentage, we'll find it by dividing the decrease in value in the value form divided by the original value, and then multiplying it by 100 to get the decrease in value percentage. Let's understand this through an example. So in this example, we have a scooter whose price was 34,000 last year, and this year the price has increased to 40,800. So we need to find the increased percentage of the price. So how do we do that? So first we'll understand what the original price is, and that is always the value that was before. And in this question, it's going to be 34,000 rupees. Then we know what is the new price, and that is 48,000. So we can find the increase in price as 40,800 minus 34,000, and that comes out to be 6,800. So let's find the percentage increase, and we'll use the formula we talked about before. So we have increase in price upon original value, or original price, into 100, and we know that the increase is 6,800 divided by the original value, that is 34,000, and we multiply it by 100, and whole thing is a percentage, and we get the final value as 20%. Let's look at another simpler way of finding increased and decreased quantity. So this is the opposite of finding the increased or decreased percentage, and we'll show how does these both interact with each other. So if we want to find increased quantity of a particular original value, and that has been increased by X percentage, we will see that through this explanation that I have done, that how it is originally written. So if we say that the new quantity is something that is an addition of what the original value was, that is the original quantity, and then increase in the new quantity, that is the increase. So if we simplify it a bit more, so we'll have it as an addition of original quantity and some X percentage of the original quantity. So we keep the original same, and then we can change X percentage as X by 100 of the original quantity. Now we know original is same in both these values, so we can take that out. So we'll get 1 plus X by 100 of original. So that is the value that we get. That is the value that we need to find if we want to find the increased quantity through a percentage value. So this is the one below here is the formula that we would use generally. So in a very similar way, if a quantity is decreased by X percentage, then using is a very similar pattern. So the decrease in quantity would be for X percentage would be 1 minus X by 100 of the original quantity, as we have done in the previous increased quantity. Let's look at some examples to understand this a lot better. So let's decrease the number 275 by 8%. So the new number would be something that we can find from the rule of thumb, or say the equations above. And because we need to decrease the value, we'll use the formula 1 minus X by 100 of original. And here the original number is 275, and X, just write that down, original number is 275 and X is 8%. So 1 minus X by, so 1 minus 8 by 100 into 275, which gives us 92 by 100 into 275, which finally gives us the value of 25. Moving on, let's try a new word example and see how these entities or rule of thumbs can be used in a real world example. So in this question, we have a particular time interval of 5 minutes 30 seconds, and it has been wrongly estimated to about 5 minutes 31 seconds. So we need to find what is the difference in these two values, or say the percentage error in this sense. So what is the actual time interval or the original value? So that will always be the one before anything changed, and that is 5 minutes 30 seconds. To make it a lot simpler, we'll just convert everything into seconds. So we have 5 into 60, that makes it into seconds, plus 30, and this comes out to be 330 seconds. Our estimate, or the new value, is 5 minutes 31.5 seconds. We'll convert this into all seconds as well, and this comes out to be 5 into 60 plus 31.5, and that comes out to be 331.5 seconds. Let's find the error. So error is basically the difference of the original and the actual value, and this comes out to be 331.5 minus 330, and that is 1.5 seconds. Now we'll find the percentage error, and that is going to be our error divided by the actual into 100. And this is a bit of a reprisal from what we have already done, or from the previous rule of thumbs that we have seen. So our error is 1.5 seconds divided by the actual, that is 330 seconds, and then we'll multiply it by 100. And this comes out to be 15 by 33%, or 5 by 11%. Let's look at another word example. This will be a bit different, and it will include a bit of an algebra as well. Okay. So in this question, we have a student. There are two students in this examination who have prepared and given the exam. So first, student A secures 32% marks in the exam, and that student fails. Student B is able to secure 42% of the marks and has got marks that is 28 numbers higher than the required marks to pass. I need to find what is the maximum marks for this examination and what is the passing percentage. So we'll first assume that the maximum marks of the examination would be X. So in our first student case, we have 32% of X is what our student A has got. So let's just name them as student A, and they have got 32% of X. And if we add 12 to it, then that becomes the passing marks. And for scenario B, or student B, that one has got 42% marks, and but it is greater than the passing marks by 28. So if we need to find what is the passing marks, we'll need to minus 28 out of it. So that also becomes the passing marks. So as these both are the same value, we can equate equation for A and B. So 32 by 100 X plus 12 is equal to 42 by 100 of x minus 28. Let's solve this, and x comes out to be 400. So our maximum marks is 400. And let's find what is the passing percentage. So we can use either of the two equations. So let's take the first one, 32% of 100, sorry, 400. Let's take the pass marks, and we can use either of the equation. That is 32% of 400 plus 12. This is for student A. So 32 by 100 into 400 plus 12 gives us 128 plus 12, and that comes out to be 140. So that's the pass marks. And how do we find the percentage pass marks? We'll just divide the pass marks by the maximum marks and then create a percentage out of it. So that is 140 by 100, 400 into 100. That's a whole percentage, and that comes out to be 35%. Now let's look at the final exercise on this percentage word problems, and then we'll move on to another topic. Okay, so in this question we need to find the population. We are talking about the population of a village. So what happens? There is an epidemic, and 2% of people die due to the epidemic. And then there's a panic because so many people died. And due to that, 14% of the remaining population left the village. And at the end of all this, the reduced population is 2,107. So we need to find out what was the original number of people living in the village before the epidemic happened, before the panic happened. So let's try and find out what happened. So let's assume that the population in the beginning, or the original population, was X. So first let's tackle the epidemic. So after epidemic, population is 2%, 1 minus 2 by 100 into X. And that comes out to be 98 by 100x, or 49 by 50x. And then after panic, again there's a number of people that left. So we have 1 minus 14, because 14% of people left, of not x, but the remaining 49 by 50 of x. And that comes out to be 86 by 100 into 49, 86 by 100 into 49 by 100 of x. So we already know that the population after the epidemic and pandemic, after the epidemic and the panic was 2,107. And we can equate it to the equation we have already found, 86 into 49 by 100 into 100 of x. So we'll easily substitute and find the value of x, and that comes out to be 2,500. So the original population was 2,500 people. And that's all for the percentages. I hope you like our video. Please like, share, and subscribe for more content like this. Thank you, and see you again.